Let's first run k nearest neighbor using the KNN method from the library FNN. So we've already run the library FNN, and this is what your textbook uses. So we have to first train, and in the train command itself, then we will specify the new data. So you will get everything in one. So let's call this knn.fnn. That's where we will save the results. All right, so we have knn. Okay, so that's the command, and that is from fnn package. Then we say train equal to, so we need to now give the data that we must use to train. All right, so we say train dot norm. Remember, we have to use the normalized data. And now we have to, the train data here is the predictors. Train.df has 3 columns. The first 2 are the predictors, the third one is the target. So for the train parameter, we have to specify the columns that contain the predictors. So since not all 3 columns are predictors, we have to specify that all the rows and then just columns 1 and 2. Okay, you can do it this way, or if you don't want to give it as a list, we can do like this as well. Okay. Then once that is done, okay, so that's our train, and the new data, okay, for which we want to generate classification. Okay, we can give the valid data here, but let's just give new.df. Okay, well, we have to provide new.norm.df. You have to be very careful. Okay, then we haven't specified what the target is. Okay, so target is the classification column, so that is called CL. So that's the target, and where is the target coming from? train.norm.df, okay, and ownership. Okay. Now we need to specify the parameter value k. Okay, how many neighbors you want to check? K equal to what? That's the number of neighbors. So say k equal to 4 or something. Okay. Now we run this. Okay, now we have knn dot fnn, okay, right here. So if you run knn dot fnn, so it has 3 things in it. Okay, the first one is the classification for the test data, so that's non-owner. Okay, and then it has 2 other attributes. Okay, the first attribute is called nn.index, and that's the nearest neighbor index. So we had 4, k was 4 for us, so it says the first nearest is the second observation, the second nearest 10th observation, third nearest first observation, fourth nearest is the 14th observation. And this attribute nn.dist gives you the actual distances. As you say, the smallest, the next one, and the next one. So if you want to look at the data, right? You want to look at the nearest. So we use the attribute function, okay, and we want the attribute forward FNN KNN dot FNN. We want the attribute of KNN dot FNN, okay, and which attribute do we want? Okay, we have to give that in a quotation mark NN dot index. Okay, so that's the name of the attribute. Okay, so run that, and then you see the attribute, and then you want the distance. Then you can say attrknn dot fnn, and the attribute is nn dist, the nearest neighbor distance, and then you get that. Suppose if you want the actual row of data from the train data set, that are the nearest ones, so then we have to say train.df, right, and we want those rows that are given by this attribute, right? And say we want all columns. Okay, if you run that, then you get the 4th observation, 14th, 3rd, and the 20th observation.